get to the meat of this, we're going to talk about Polya's method, right? These are the steps that we're going to follow to tackle the proofs. And again, you can use this method for any kind of problem solving that you encounter. It's just a general 4-step method that's going to tell you how to tackle a problem. And in this case, we're going to see how these 4 steps apply to mathematical proofs. The first step is always to understand your problem. In the case of proofs, that usually means definitions. Definitions are usually going to be the core of your proof. If you don't know the definition of something that you're trying to prove, you're probably not going to know where to start. If we go back to the even numbers example, you need the fact that if n is even, that means that it's equal to 2 times a for any integer a. And that fact is used in the proof, and without it, you can't finish the proof. You need to know the exact definitions of the terms that you're working. You want to know the context of what you're working with. Right? In the case of the even numbers, you're working with integers. Right? There's certain rules that integers follow. There's certain rules that real numbers follow. Some of them are similar, but they're not exact. You want to know the context of your problem. In other words, usually that means knowing the domain of your problem, right? What set of numbers are you working with? Once you go to topology, you're not really working with a lot of numbers also, so you want to know what set of objects you're working with. So it applies to everything. Know the context of your proof. You also want to make sure you know what facts or theorems could be relevant to your proof. We'll see once we look closely at the even number example, we're going to use the fact that if you add 2 integers, you get another integer. That's also a fact that's important about integers. You need to know your context. That will tell you the facts and theorems that apply to the kind of proof that you're working. The second step is to make a plan. When you're making your plan, usually it helps to plug in some values if you're working with formulas, if you're working with numbers. You can plug in values to give you an idea of the problem that you're working with, right? When we talked about the even numbers, we talked about if you add 2 and 2, you get 4, it's an even number. If you add 2 and 4, it's 6, it's an even number, right? You're plugging in values and testing to see if the proposition is true, and that should give you an idea about how the proof should flow. Then you're going to write an outline for your proof. So a lot of the times, the proofs that people turn in will really just be more of an outline of a proof than a proof itself. And that's where the writing more comes in. An outline is going to give you the process of the proof. It may give you all the steps that are necessary in the proof, but usually you're going to have to fill in a little bit of the meat of that proof, right? Add the justifications, write in complete sentences so that your audience can understand. And lastly, you can draw a picture, right, to help you get an idea of where you're going with your proof. Then you're going to execute your plan, which usually means following the steps in your outline and filling in the rest of that proof, right? Writing in complete sentences, making sure everything is clear to your reader. We're writing proofs. Somebody's going to read this. They need to understand what you're doing. Lastly, you want to always look back and reflect. That means you're going to review your proof. Does everything make sense to you? Is there any additional information that you didn't include in the proof that maybe in your head you used to understand what was going on? In a proof for the even integers, you skip including the fact that adding 2 integers gives you another integer. That may be clear to you, maybe it won't be clear to your reader. You want to think, is there anything else that goes into this proof that I haven't included in here? Is there any fact, any theorem that I'm using in this proof but I haven't stated? And again, your proof should read like an explanation, right? It should go from your assumptions to your conclusions in a series of logical steps.